Okay. Alkyl halides are colorless and pure compounds. I mean, if pure compounds, if you can take, those are the colorless compounds. Pure compounds are the colorless compounds. But if alkyl bromides and alkyl iodides going to expose to the air, nothing but air is nothing but here sunlight. Okay, they will become colored. They will become deep color. Okay, maximum volatile compounds. If you can consider volatile compounds, volatile nothing but they are going to evaporate easily. They are going to mix up with air easily. That nature is called volatile nature. Just remember. So if you take volatile compounds, they are having sweet smell in nature. Sweet smell. Volatile compounds have sweet smell. Okay. Pure alkyl halides are colorless compounds, but if alkyl bromides and alkyl iodides exposed to the air, they are going to become change into deep color. And if you can take volatile compounds, volatile alkyl halides, they are their nature is the sweet smell. They are going to produce a sweet smell. If you consider their melting points and boiling points, if you consider their melting points and boiling points. So now you can check about melting and boiling points. MP melting point, MP is nothing but melting points. BP is nothing but boiling points. Okay. Methyl chloride, methyl bromide, ethyl chloride, and chloroform. Chlorofluoromethanes are gases at a room temperature. If you consider at room temperature, at RT, I'm writing RT is nothing but room temperature. At this condition, methyl chloride. Methyl chloride is nothing but CH3Cl. Okay, methyl bromide. CH3Br. Ethyl chloride. C2H5Cl. Ethyl chloride. And some chlorofluoromethanes. Chlorofluoromethanes are nothing but in yesterday's class I told you in the case of polyhalogen compounds, CCl2F2 is the fluorochloromethane. Okay, fluorochloromethane. These are gases at room temperature. All these compounds are gaseous particles. Gases. Someone raised their hand. Do you have any problem? Just message me. I can see. Okay. Just message me. Methyl chloride, methyl bromide, methyl iodide, and some chlorofluorocarbons are gases at room temperature. If you consider higher members are nothing but more than two carbons. Here we have seen only up to two carbons. Higher alkyl halides. Higher alkyl halides are Rx I am writing. Rx is nothing but alkyl halide. Higher alkyl halides are liquids or maybe solids. Depends upon the condition. Okay, liquids or solids. Higher alkyl halides are the liquids or maybe solids. These alkyl halides are polar in nature. Alkyl halides are having polar nature. polar nature. If you take their liquid state, they are going to form intermolecular forces. Intermolecular forces. Intermolecular forces because of their polarity nature. Especially these intermolecular forces are nothing but dipole and van der Waals forces. These are the special type of forces. Those are dipole. Someone sent messages. Okay, I think this is not relevant messages to this class. Okay, dipole interactions. Dipole interactions and van der Waals forces. Van der Waals forces. Okay, these are this type of intermolecular forces are present in the alkyl halides are in solution state. Okay, because of presence of such type of intermolecular forces, these are having high high boiling points. These are having high BP is nothing but boiling point. High boiling points for chlorides, high boiling points for chlorides, bromides, and iodides. See, listen one more time. I'm going to repeat this. I need to go to the next page. Before that, you can take screenshot. One more time, I'm going to explain this. Alkyl halides are maximum. If you take pure alkyl halides, those are the colorless compounds. But if you can take bromides and iodides, alkyl bromides and iodides, if they are going to expose to the light, if they are going to expose to the light, then they will become deep in color. When exposed to the light, they will become deep in color. Okay. And if you take volatile compounds are nothing but they are going to become easily mix up with the air. So if you consider volatile alkyl halides, they are having sweet smell. See here I mentioned, okay, sweet smell. And if you consider their melting and boiling points here, melting and boiling points, uh, for higher alkyl halides, melting and boiling points are more because they are having intermolecular force of attractions. These intermolecular force of attractions are nothing but here dipole interactions and van der Waals forces. And because of presence of these forces, these are having high boiling points. For high boiling points, especially applicable for chlorides, bromides, and iodides. If you consider simple alkyl halides, see here I mentioned methyl chloride, methyl bromide, ethyl iodide, chlorofluorocarbons. If you consider these simple alkyl halides, these are present in the gaseous form. So we can't mention melting and boiling points for such type of gaseous compounds. Is that clear, all of you? I'm going to the next page. So, one more important point is here. The melting and boiling points are more when compared to the simple hydrocarbons. Here I am writing again. Melting and boiling points are more than hydrocarbons. HC I am writing. HC, hydrocarbons. Is that clear, all of you? Just please take a screenshot. I am going to the next page. Please take a screenshot. Any doubt you have in this space? Just let me know. Yes, it's clear. Very good. Thank you, Amma. Sai, Akila, and another one. Completed. Thank you, Amma. I'm going to the next page. Yes. So just now we have seen that is alkyl halides are having intermolecular force of attractions and these are having polar in nature. I told you. So if intermolecular force of attractions are more, if inter I means inter, M means molecular, F means force of, A means attractions. If intermolecular force of attractions are more, then the molecular size will be more. Molecular or molecule size will also be more. Okay. And it will have more electrons. Number of electrons will also more. Number of electrons will also more. So according to this, if you observe the order of melting and boiling points order for alkyl halides, see here I am writing boiling point order. Boiling point order I am writing here. Alkyl iodide is more boiling point when compared to the alkyl bromide. This alkyl bromide is more boiling point when compared to the alkyl chloride. This is more when compared to the alkyl fluoride. This is because with the increase in size and mass of halogen atom, the magnitude of van der Waals forces will also increases. This is the same thing I have mentioned. Okay, the van der Waals forces, force of attractions will also increases because of BCZ means because of size increases, size increases, mass will also increases, mass of halogen, especially mass of halogen. Here you can take mass of halogen increases. Then magnitude of van der Waals forces will also increases. Then magnitude is nothing but intermolecular force of attractions. Okay, magnitude of magnitude of van der Waals force of attractions. Van der Waals force of attractions increases. Is that clear, all of you? Is that clear why bigger size molecules are having more boiling point when compared to the smaller size molecules? If intermolecular force of attractions increases, molecular size will be increases and the number of electrons will be increases and mass will also increases. Mass of halogen here especially I am telling you. Then magnitude of van der Waals force of attractions will also increases. That is the reason the boiling point order is looking like this: alkyl iodide greater than alkyl bromide greater than alkyl chloride greater than alkyl fluoride. Amma, this one is fluoride. I just write repeatedly two times chlorine. Just this one, correct it. Fluoride. F. This is the F. Okay. If you compare boiling points of same alkyl halides, I mean homologous series, if you can compare, here I am writing methyl halide and ethyl halide C3H7X. This is the propyl halide. Okay. Methyl halide is lesser boiling point than ethyl halide. Ethyl halide is lesser boiling point than propyl halide. This is here, see, from left to right, the mass will be increases. Left to right, mass of alkyl halide will be increases. Mass of Rx will be increases. Then boiling point will also increases. Is that clear, all of you? Any doubt is here? And one more important point here I am writing. If you can take isomeric halides, if branching increases, the boiling point will be decreases. Here I am writing C4H9Br. This is the straight chain I am writing. This one straight chain. C4H9Br is the straight chain. So next you can take branched chain. CH3, CH2, CHBr, CH3. This is the branch one. And another branch I am going to take here. CH3, CH3, tertiary butyl bromide, this one. First one is the N-butyl bromide. This one N-butyl bromide. What do you mean by N-butyl bromide? I told you in the case of nomenclature of alkyl halide. Okay, alkyl halides. Once you can check there. Okay, N-butyl bromide. This is the secondary butyl bromide. This one is the tertiary butyl bromide. BB, I just write it, okay? Just try to understand. If the branching increases, the boiling point will be decreases. Here, see, my dears, I am telling you, this one, N-butyl bromide is having 375 boiling point. Boiling point of N-butyl bromide is 375 Kelvin. 375 Kelvin. Okay. And secondary butyl bromide is 364. This is one exception. Just try to remember everyone. 364 Kelvin. And this one is 346 Kelvin. See what I am telling here. If the branch increases, boiling point decreases. This is different when compared to the previous condition. Everyone take screenshot. Any doubt you have here, just let me know. Is that clear, all of you? I'm going to the next page. Make it fast because the I think maybe meeting will going to be end within a few minutes. So that's what I'm telling you. Yes, very good, Amma. Very good. I'm going to the next page. Yes. Till now we have seen about only aliphatic alkyl halides. Okay. Aliphatic are nothing but alkyl halides. You can remember. Now we are going to check about aromatic things. Aromatic. Nothing but aryl halides. I am telling you here. If you take aryl halides, First one,